Okay, thank you for being here. First of all, we have, as Joe was mentioning, we have been working with YellowScan for the last 4 years, I would say, and it's very nice to see how the community has grown. We started from 3-4 people, and then we are here now with more than 60. That's really great. So today I want to present a new post-processing mode that we have introduced in PostPack 8. This is called Post-Process RTX. And the title perhaps is self-explanatory. So it's Post-Process RTX for mapping from UAVs without base stations. So I hope it's clear. If you have any questions, you can interrupt me whenever necessary. Okay, so let's start with RTX. So RTX is a real-time differential correction services from Trimble. So this is a service that it was introduced years ago by Trimble, mainly targeting the agricultural market. So it's a dedicated network of reference stations, multi-GNSS stations, which are tracking GPS, GLONASS, Beidou, Galileo. What is really important of this network is that it's very secure. So it's been recently certified with an integrity layer, which ensures the correctness and the uptime reliability of the data. So this allows RTX to be used for safety-critical applications. And it has started to be used in automotive applications, which it's quite good. So the data that you're getting out of this network is of a very good quality. It is based in the real-time computation of very precise ephemeris and atmospheric delayed models. So this is RTX, this is real-time. This is a service that Trimble is offering for different markets nowadays. And it enables an accuracy approaching to RTK. So in this case, when you use RTX, you don't need local base stations. So you're using this network of reference stations, which is managed by Trimble. So how does it work? So basically, what we have is a number of base stations worldwide. With different servers. We have a server in the US, we have a server in Europe, Germany, and a server in Australia. And so the data is transmitted to the end user via L-band or via IP cellular. And then you can get centimeter level accuracy out of it. We have a convergence time, so the solution has a convergence time. So unlike the GNSS, which eliminates the atmospheric errors by differencing them out, RTK is reducing the errors by what they call producing the global and regional models, so atmospheric models. So basically they are modeling, they're estimating errors, and they're applying those corrections to the carrier phase measurements. So in order to get centimeter level accuracy data. So the time to convergence to the final correct ambiguities is a function of multipath and the geometry of the satellites. We currently have 2 types of services. Trimble is offering 2 types of services. One is called the standard RTX, by which they are using a global geonospheric model with a convergence time of less than 5 minutes. So this is available globally, anywhere in the world. You are getting this service standard RTX. And then they recently started to offer a new service. This was by the beginning of last year, it started to be rolled out. Nowadays, it's pretty much covering the whole of Europe and also the US. It's very well covered. And so it's using regional ionospheric and tropospheric models. So in this case, you're using networks with a higher density of base stations. And so they are getting here to convergence time of less than 5 minutes. So in this case, we have started to see then the opportunity to offer the RTX technology to the UAV mapping market. So the coverage, as I was mentioning, so Europe is pretty much covered with Fast RTX, and that is the coverage for the US. So what is the sort of performance that we have seen so far? So this is a comparison between the typical RTX and the RTX Fast. So if you look at it on the typical or standard RTX, we're getting on 95% of the time to a convergence time of about 6.6 minutes. So that is the time that we need in order to get to a centimeter level accuracy, which is below 5 centimeters. And then the RTX Fast is providing the same results, but with a convergence time that is less than 1 minute. So the results that we have seen so far, and we ran some tests with YellowScan by the end of last year. They've been very, very good. We're having very good accuracies with very good convergence times. So this is quite promissory. As I was mentioning before, the RTK Fast uses a denser network of reference stations. So the way they do it is that they use a network in which the separation between reference stations is no more than 200 kilometers. And in this way, they can provide this higher performance level. So last year, by Intergeo last year, what we did is that we introduced the RTX. So we introduced the RTX mode into the post-pack 8. So we released this new mode, which is called post-process RTX. So what we are doing, we're basically accessing to those RTX corrections in post-processing. The service is cloud-based. It's available as a subscription. So we have two different plans. We have a plan which is a 6 months plan, and we have a 12 months plan for it. And it's accessible globally via an internet correction. So we post-process as post-pack does it. We post-process forwards and reverse. So we provide a combined solution. The corrections are ready, available within minutes after the mission. So this is what Trimble has called the real-time PPP, the new real-time PPP technology. So it's very good because you can get the corrections just. I mean, what they have seen is from 2 to 3 minutes after the mission, you can access to the corrections. The accuracy that we are promoting on the X-Specs is less than 4 centimeters in the horizontal and less than 6 centimeters in the vertical. In reality, we're getting better than this. So what we have been finding out is more 2 centimeters in the horizontal, 4 centimeters in the vertical. So how it works? So, well, as mentioned before, there is a network of reference stations from Trimble, which is computing those precise ephemeris, clocks, orbits, biases, and it's generating those global and local atmospheric models. The precise data from that network is used by postpack. So what we have to do is we have to send a trajectory to the RTX server via internet. And then we recover the corrections. So we recover a virtual moving base station created at trajectory epochs. And in post-pack, the post-post RTX is resolving those integer ambiguities. It's running the solution in forward and reverse, which allows us to improve the convergence time as well. And it produces a high accuracy aspect with no convergence time. So basically, the converged solution from the forward pass may be used as a seed for the backward direction. So which are the requirements for post-process RTX? We need to use the latest version of postpack, which is called postpack 8. There is a subscription for post-process RTX. We require the connection to internet. And we need at least trajectories of 30 minutes for the standard RTX service and 50 minutes for the fast RTX. Even if the convergence time that we're finding out is the one that I showed you in the beginning, less than 7 minutes and less than 1 minute, for security reasons, what we are advising on X-Specs is to fly at least 30 minutes for the standard RTX service and at least 15 minutes for the fast RTX. You need clean GNSS observables, so free from data gaps and with minimal cycle slips. So this can still be a challenge, but from the different tests that we have carried out in the last 4 months, it hasn't proven to be a problem. So, and you need a calibrated antenna. So this is provided by us, is an antenna that we normally supply with our systems. So how does it work and the workflow? So as I was mentioning before, we send a trajectory to the Trimble cloud, so the RTX server. Then we localize those corrections, which are returned to us via internet. And then we run the RTX aided inertial processor. So we combine that with the IMU data, we combine that with rover observables, and we generate the SVET file at 200 Hertz. So I wanted to say that this is an alternative post-processing mode. So how we see post-process RTX is an alternative to single base or alternative to SmartBase. So what we have done in post-pack and we're trying to offer in post-pack is different alternatives that will allow you to work in all of the different kind of scenarios. Which are the main benefits of post-process RTX? So the first one that we see is improved efficiency. So it allows you to reduce the working time versus other post-processing modes. So if we take a traditional workflow where we start preparing the flight, then we fly, and the mission import trajectory and run the processor. If you see the, compared to a single base workflow, well, the flight preparation, you won't have to use a base station. So you won't have to set up a base station, you won't have to start collecting data with it. So you would have some time savings over there. Then when you end the mission, you won't have to take care of the base station as well. So this is something that brings efficiencies to the workflow as well. I think I would say that perhaps the biggest savings in terms of time is going to be at the moment of importing to trajectory, as you will need to import the base station data. You will not need to configure your base station in post-pack and so on. So you will need to do that, and then you will run the GNSS inertial processor. So we think that the savings in terms of time are between 20% and 30% versus a single base processing mode. Second benefit is how robust is the solution. So the solution is using gap-free secured base stations, so which are monitored by Trimble on a continuous basis. And we're using the multi-GNSS base station data, which is run in forward and reverse, which allows us to improve the solution as we do it nowadays in post-pack. And the coverage is anywhere in the world. So you are covered anywhere. So as I was mentioning before, so the data is available within minutes after the mission. So this is just comparing the PPP IGS products against the post-process RTX. So if you look at it now, PP-RTX is offering an alternative which it was not existing. So with PPP, even if you get the IGS Georeferencing product, that you will need to wait from 3 to 9 hours. And the other is that it simplifies or enables the large area UAV mapping. So this is an example of a corridor where you need to have different base stations. So normally nowadays we recommend to use a baseline of no more than 20 kilometers between base stations. So if you look at this corridor, you could start from one base station and then set up multiple base stations depending on the length of your baseline. With post-process RTX, you won't need local base stations. So thinking in fixed wing, high endurance UAVs, which we are finding more and more on a global basis, I think this technology is going to be enabled for them, because those fixed wing UAVs, which can fly sometimes 1, 2, 3 hours, and they fly these long corridors where sometimes they need to set up multiple base stations. So the fact of not having to use base station, it's a very useful future. We ran some examples with a company called Dell Airtech last year of a corridor that they flew of about 300 kilometers. And the time savings by not having to set up the base stations, they were impressive. So the project was finished in a record time for them because of the fact that they didn't need to go through all of those logistics. Sometimes you work in areas as well where it is not easy from a logistics side to set up a base station. So which are the limitations of post-process RTX? Well, one of the limitations I think nowadays is that it works optimally with fully open sky, clean observables, minimal multipath, and minimal cycle slips. So this could be a challenge for UAV applications. And we're conscious of that. We have started to run tests, so we will be running those tests all of this year. But we believe that it could be managed. The other is that the Fast RTX is still limited to certain areas of the globe. It is expanding, but it's still limited. So with the standard RTX service, you still need 30 minutes trajectory duration, which means that it can be challenging for short flights. So this is something as well that we still need to expand Fast RTX. It's moving very fast. All of Europe is covered nowadays, and Trimble is working more and more in order to cover the whole world with Fast RTX. And we think it's gonna be expanded in a decent time. So it's gonna come. The third limitation that we have is the vertical accuracy, which is not yet as good as a single base. So it's still not as good as when you use a local single base station. Some key applications for post-process RTX that we start finding out. Well, as mentioned before, long corridors, long baselines, hard to access areas where you cannot set up a base station, multiple short flights, marine seafloor mapping. And I would add to this one, I would add areas with a low density of course stations. When you're flying in areas where you cannot find course stations and it's not easy to set up a local. So performance. So we did 100 airborne data sets were analyzed at about 220 hours in different countries. This started a year and a half ago. Flying at different altitudes from 0.16 to 8.7 kilometers and different kind of platforms as well. And we use as a reference our Applanix SmartBase mode as that solution. So these are the kind of results that we were getting, we found out. So if you look at it, RMS, northeast, it's about 2 centimeters, and then we have a vertical about 5 centimeters. 95% of the case, we're going to 11 centimeters. In terms of convergence time, so we went to same analysis, gap-free data, minimal cycle slips. We use the same reference as SmartBase. And the average time, well, the minimum time it took us, it was in forward mode, 5.4 minutes, in backburn mode, 4.4, and maximum time you see there, 40.42, 9.9, 37.5. This is improving. The tests that we carried out, these tests were ended last year, so by mid last year. So we need to go through this exercise again to get to the latest figures. More on the ionospheric model with faster RTX, so 5.4, slowest convergence, as I was mentioning before, 49.2. And if you look at it, well, here in the graph that we have there, so you have the forward pass, then you have the backwards, and then you have the combined. So if you look by using the forward, the backwards, so we improve the convergence time. So we get to almost what we call in post-processing convergence-free solution. Now, what about if you lose your fixed position? So to reconverge is very fast. So the filter saves the memory of the ionospheric and atmospheric estimates, ionospheric and tropospheric estimates. So normally what we will have is that the Kalman filter will save the memory of, will retain those estimates. Another main advantage of post-process RTX, it can be used to survey your base station. So you can send the base station file, you can send it to the cloud, and then you can recover the precise coordinates in postback of that base station. So we were talking about that with someone who was asking me for this option. It is available 1 hour after collection. And this is very useful. We have seen that a lot of the customers that they have started to use post-process RTX last year with manned platforms, they are using more and more this capability. So what do you need? You need minimum 1 hour to wait after your mission, and then you need a maximum of 24 hours of dual frequency base station. It's compatible with files T02, Linux 2, or Linux 3. And you need an internet connection. The absolute accuracy that we have found out is less than 2 centimeters in RMS. So it can be used to establish initial coordinates or to check existing coordinates. And this is free. So this is available in PostPack 8. So for all of you that are using PostPack 8 nowadays, you can go and you can use the post-process RTX to survey the precise coordinates of your base station. So some examples of applications where post-process RTX can be useful. So here we're going to present 4 examples. An example of a single dedicated base station against PP-RTX, Applanix SmartBase with cores, and then SmartBase with a dedicated base. So when we are combining the SmartBase with a local base station, and then the post-process RTX. So here's an example of a dedicated base. So this is an example that we flew in Canada, in Toronto. So located at an airport, the project area was 55 kilometers away. So the accuracy was reduced because we were exceeding the 20 kilometers. So the solutions were, okay, either we add another base station in the project area, which was not simple. Then we could use a virtual reference station, so a course station, but we didn't find a course station, so we couldn't do that as well because there were no course stations. So how we solved the scenario? We solved the scenario by using the post-process RTX. So this is something that nowadays, for example, it's a common case where we have customers where they find a course station, and then 20 kilometers. At 20 kilometers, they don't have any more base stations. So what they need to do is that they need to use a local base station, and they need to complement the network. So sometimes it's not easy. Sometimes it's going to add time, so it's going to add complexity. In those cases, well, post-process RTX, it's going to be a good solution for that. Here we have another scenario where we have a SmartBase course network. So in this case, we're using public or private course stations. So we're using SmartBase. So we have the problem which the distance between those course stations is too large. So we normally advise to have a distance between course stations of no more than 50 kilometers. In this case, is bigger than that. So the solution is that we can increase density by implementing local base stations, or if not, you could use a post-process RTX. Augmented SmartBase, and here as well is the same scenario where we have a network BRS, existing cores and dedicated. So instead of adding a new station, so we use post-process RTX. So this is a comparison of accuracy's performance between post-process RTX versus dedicated base. And this is what I was mentioning before, that in the vertical, we're still not getting the same accuracies as we normally get with a single base. So you see here, for example, the vertical there, and how the difference between post-process RTX and dedicated base is about 3.5 centimeters RMS. This is the same example, but against SmartBase. So I don't know how familiar you are with SmartBase. I don't think you're using SmartBase nowadays. SmartBase is a post-processing mode that we have in PostPack by which we can post-process using multiple course stations. So we can post-process using, we need at least 4 course stations, and it could go up to 50 course stations. So in this case, it's the same comparison. We're comparing the accuracies, the performance between the post-process RTX versus SmartBase. And if you look at it, again, the vertical is not as good as the SmartBase. We're working on this. So we're working on trying to find out. We think it's due to calibration, and we're trying to test that. We're testing that more. This is the same example, but in this case, we're comparing the post-process RTX versus SmartBase. plus a dedicated base. So this you have course stations and you're adding a local base station. So here is better because we're getting a difference of about 2.77 centimeters. Okay, so some future work that we're working on. So now we have implemented the post-process RTX in PostPack. We're working on implementing the real-time RTX for real-time mapping. So we're about to introduce a new antenna for L-band, which is going to be able to track the RTX corrections in real time. For this, we need to update the library in PostPack for the antennas, and now we're testing that antenna. So it's in beta test mode nowadays. So what is the idea behind offering the real-time RTX service? Is because we're seeing applications in which it will be useful to get centimeter level accuracy in real time for mapping purposes. So some of the applications that we're finding out nowadays for LiDAR, one is fast temporal analysis, landslide monitoring, construction monitoring, change detection. I saw a presentation this morning from someone which was showing the point clouds being used for change detection operations. And also, we are finding more and more applications such as forensic analysis or security. So for those purposes, we are trying to implement this new antenna so we can start offering the real-time, the RTX service in real time for mapping. So if you're interested in trying the post-process RTX, we have demo licenses. We want to run, as I was mentioning to you, we need to test it more extensively. So if you want to test it, please just ask YellowScan. We have temporal license, which we could provide to you. We have temporal license from 1 to 3 months. So you can give it a try. You can see how is it working and the results. And the only thing that perhaps we will ask in exchange is perhaps to get some data sets from you. So we can start using those data sets as well for this comparison purposes. Okay, so thank you.